So, hello dear students, I hope you are doing well. So, this is our lecture number 3. In previous lecture, in our BWE series, okay, we have discussed the basic terminologies of DC. We have seen some symbols in DC and Ohm's law. Now, here we have come with the topic voltage division rule and current division rule. Okay, my aim is to provide you very specific topics or the things from the BWE subject with minimum time. Okay, so let's start our topic today. First, let's see the current division rule. Okay, the current division rule. Current division rule, from the name you can assume that it's divide the current. Okay, by using this current division rule we can find the value of current in a particular branch, but current division rule can only be applied to a particular branch or to particular two branch or three branch or four branch when they are connected in parallel. Okay, when they are connected in parallel, so applicable to parallel branches. Okay, this is applicable only to the parallel branches here, and branch only when the branch resistance and the total current supply value we know. Okay, that is, these two things are known, the branch resistance value and the total current supply. Okay, so I have shown here one circuit. Here two branches are connected in parallel. The voltage will be same through because they are parallel. Okay, across all these branches or this resistance. Okay, here current supply, total current supply is IT. Then first branch the resistance R1, second branch resistance R2. Okay, this R1 and R2, this branch and this branch are connected in parallel. For the parallel, what is the condition? The voltage must be same, and where the branches are connected, both the end are connected separately but at the same point. Means we have one branch, we have another one branch, we have another one branch. We'll call it parallel connection when all three branches are connected at one place or one node or one junction. The opposite side also they are connected in one place. Okay, this connection we can show like this also. We can directly short it, they are parallel. Okay, similar here we can short it, they are parallel. R1, R1, R2, R3. These are the resistance value of each branch. Okay, so the condition for the current division rule is we can apply it only when the total current supply is known and the resistance of each branch is known. Okay, resistance of each branch is known, and they must be connected in parallel. Parallel means another, in one side all the branches are connected at one point, in another side all the branches are connected in one point. This is the condition for parallel. Okay, so the total current is divided in these two branch. Okay, total current is going IT, and that is from IT, I1 is supply is going here, I2 current is going across these two branches. So we can calculate I1 and I2 by applying current division rule by like this. For if you are calculating for branch 1, what is the value of current I1? I1 is equal to total current IT multiplied R2 by R1 plus R2. What is this? It's the resistance of the opposite branch. And means suppose I1, we are going to calculate the I1. So I1 is this branch. So we will hide this I1 rest of the resistance. We will keep that resistance upside. Okay, the resistance is R2, another branch. We have two branch, So carefully, we have two branch. We want to calculate the current following across this first branch. So we'll hide this first branch. We have the other branch, that is in other branch the resistance value is R2. So we'll keep the R2 upside. Then the total resistance of both the branch R1 plus R2. Okay, this is very simple. For R2, for this branch I2 value, I2, I1, I2 total current into, we want to calculate across this branch, so we'll hide this branch. Then we have this another one branch. Okay, so this is in this branch the resistance value is R1, so we'll keep the R1 upside, then divided by total resistance. Okay, this is so simple. Just keep it in mind for current division rule. Total current into the other branch divided by total branch. Okay, other branch resistance divided by total branch resistance. Okay. Then voltage division rule. Voltage division rules also, it's applicable on series connected. Series connected means if we have one branch like this, another one branch like this. Okay, when it will be series connected? When same current is following through this branch. Same current must follow through this branch. If we connect this one, if I current is following here, so same I current will follow here. If we have another one resistance, the same I current will follow. Okay, this is series connection, means only one end of the branches are connected. Okay, only one branch of that branches are connected. Series representation must, this is, okay, this is R1, R2, R3. Okay, so branch resist, so the same condition, we need to know, we have that branch resistance value and the voltage, total voltage. Voltage for voltage division rule is applicable only when the branches are connected in series. Okay, or components are connected in series, and we know the total resistance, total supply voltage and the resistance value of each branch. Okay, so total voltage in series, keep in mind, in series voltage get divided and in parallel current get divided. Okay, so total voltage here Vt is equal to VR1. VR1 is the voltage across this R1 resistance. VR2 this voltage across R2 resistance. Okay, across. If we talk about current, then we will say through the R1, through R2. Current through R1 and R2 is same, that I, but voltage across these two resistors or voltage drop is different thing. Okay, VR1 and VR2, these two value are different. So here for first VR1, if you want to calculate VR1, first see VR1. For VR1, total voltage in current division rule, it was total current. Okay, total voltage multiplied R1. We are calculating voltage or voltage drop across the R1, so we'll keep the R1 value up. Okay, upside, then total resistance. For VR2, voltage drop or voltage across this R2, so total voltage into R2 divided by total resistance. Means, see, for current division rule, if you want to calculate the current through a particular branch, okay, so we'll hide that one. If we have we have another one branch, we'll put the resistance of another one upside then total resistance. But for voltage, calculating voltage by applying voltage division rule, we need to keep total voltage into, we need to keep the resistance of that particular branch or that particular resistance value across which we are going to calculate the voltage, that is upside then total resistance. Okay, so before applying this, you need to be clear about the parallel connection and series connection. Parallel connection, voltage is divided. Okay, voltage is same. Okay, in parallel connection voltage is same, current is divided. But in series connection, current is same but voltage is divided. Okay, so for today's class, that's it. We'll come up in the next class with KVL, KCL, and we'll do numericals also. Okay, so bye bye, enjoy your time, and if you, it's okay, leave it, bye.